we are going to now basically move from the shift of the why and the why KSC to tangible real-world examples of the successes either now or in the future that are going to be possible or are currently possible, not only in Pittsburgh, but in West Virginia, Ohio, and all the wonderful cities that comprise our 3 states. To sort of kick us off in that narrative, it is my pleasure to introduce LaShawn Burton-Falk, who is the Executive Director of Manchester Citizens Corporation, and she will be introducing John Thornton in turn. Please welcome LaShawn.
Okay, so good morning, good and beautiful people. What an exciting opportunity to be here with you this morning. My name is LaShawn Burton-Falk, and I am the Executive Director of the Manchester Citizens Corporation, the local CDC for the Manchester community, where Astrobotic and Moonshot Museum reside. I am grateful to be here with all of you today and share that as an African-American woman, I had the fortune to lead an African-American organization in a majority-minority community, a once-in-a-lifetime opportunity, and to be capable of effectuating change for people who look like me. As a community leader, we look for partnership, relationships that build opportunity and access to jobs, brick-and-mortar density, and economic growth, but most valuably, education. Astrobotic, by way of the Moonshot Museum, has had the ability to check all of the boxes for our community, and in the role that I contribute to in and for my community and region. As a result of this gift, our region is getting generations of Black and brown children to be adults that will now have access to space in ways beyond imagined. For that, I am humbled, and allow me to introduce a man that has checked all the boxes. John Thornton has grown Astrobotic's business of delivering affordable space robotic technology and planetary missions by attracting technology contracts, equity investments, and payload customers. Under John's leadership, the company has booked 3 lunar missions with its Peregrine, Griffin, and Moon Ranger spacecraft. At Carnegie Mellon University, John led the build of the Scarab, a NASA concept rover for lunar drilling, and the first rover to carry a prototype of the NASA Resolve payload. The NASA Resolve will now be flying to the lunar south pole of the NASA Viper rover aboard Astrobotic's Griffin lander. Thornton also founded Carnegie Mellon University's Advanced Composites Lab, a research training, design, and manufacturing program specializing in high-performance, lightweight composites for robotics. Please allow me to introduce to you the man that checked all the boxes, John Thornton.
Thank you, LaShawn. And thank all of you for coming here today. What an exciting day for Pittsburgh and this region, for representing everything that we are already doing, leading in space. So I'm the CEO of Astrobotic. We got started 15 years ago this year, right here in Pittsburgh. We have 2 lander missions on the books and 1 rover mission on the books. Our first mission flies later this year. Our second mission flies in 2023. We have a 47,000 square foot building 1 block from here that you're all invited to come tour later tonight. We now have 168 employees under roof and growing. And we deliver cargo to the moon. That's our core business. We take payloads from all over the world up to the surface of the moon, and we provide power and communications for those payloads that come with us. We have 21 payloads on our first mission, 10 from NASA and 11 from non-NASA partners all over the world. 7 nations will land on the surface of the moon with our very first mission. 6 other than us in the US. That will triple the number of nations that have ever landed on the surface of the moon. So fundamentally, we're a delivery service to the moon, but when you get to the moon, you also want to be doing things on the surface. So we also have a mobile payload delivery service as well. So we have small rovers that can drive off and provide cargo for customers. We also have a space robotics group that really leverages the capabilities that's coming out of this region, doing advanced perception, navigation, autonomy capabilities in space. And in particular, they are building our precision landing sensor that can land our landers within 100 meters of a target down on the surface of the moon. That's going to be very, very important for the future of exploration and science on the surface of the moon. But first, is that going to go? How do we advance the slides? Oh, there we go. Okay. Oh. And back. Okay. So we're going to start talking about the moon. So the moon is why we got started as a business. For context, it's about 238,000 miles away. And if you think about the odometer in your car, that's actually not that far. I mean, my car has 165,000 miles on it. I'm most of the way to the moon. If you think about Mars, Mars is much further away. It's 34 million miles away. So just as a comparison, if you were to drive to the surface of the moon in your car at highway speeds, it would take about 6 months to get there. If you drove to Mars at highway speeds, it would take you 65 years to get there. The moon is our nearest neighbor. It's the closest thing to Earth by far. It is the practice ground. It is the place we are going to learn to live off the land and develop the technology and the capability to live off another planetary body. The moon, as we see it in the night sky, might appear black and white. It might appear that there's not that much going on, but in fact, it is a bountiful world, but it can have its harsh side too. There is vast quantities, as we suspect, of frozen water at the poles of the moon. And that's incredibly important. Water is abundant here on Earth. Right here we're at, of course, a beautiful view of the 3 rivers of Pittsburgh coming together. But water is heavy. It's very energy intensive to get water off Earth. And why do you need water in space? Of course, for astronauts to drink. You can split water and you have oxygen to breathe. But perhaps most importantly, you can split water and condense it and make rocket fuel. So water could be the fuel that powers the new space ecosystem in space. You could fly things back and forth from the moon with moon fuel. You could refuel spacecraft at the surface or at the moon vicinity to go deeper space outward. There was a study that MIT did that thinks that you could potentially reduce the cost to get to Mars by 50% if you were able to refuel at a gateway station in the vicinity of the moon. Dramatic changes could be possible just by accessing that water. The other on the moon is there's actually interesting possibilities for metal deposits. And we think about a constrained resource here on Earth. We think about all of the rare earth metals and all of the resources and how hard it is to get here on Earth. But there's vast quantities of resources in space. There's a rock orbiting our sun today that has more metal in it than mankind has ever mined. And that's out in the asteroid belt, worth trillions of dollars. And these same rocks and impactors have been hitting the surface of the moon. And the interesting thing about the moon is the moon doesn't have volcanic activity and tectonic plates that have turned over the soil, so all those impactors are still sitting on the surface. So it's entirely plausible that there could be some really interesting deposits here on the surface. And over the long time, I would much rather be mining space than our delicate blue planet here, the only planet that can support and sustain life in our solar system. The moon also comes with its own hazards, though. The temperatures on the moon are extreme. The moon, as we see it in the night sky, the lit part of the moon is 120 degrees Celsius, or about 250 degrees Fahrenheit. When the sun sets on the moon and it goes into shadow, it can get down to liquid nitrogen cold. And that's 2 weeks above boiling temperatures, 2 weeks of liquid nitrogen cold. That's 1 day on the surface of the moon. There's a radiation environment on the moon that is more extreme than here on Earth, so that is a more challenging environment for our astronauts. There's a vacuum on the moon that makes it very difficult to select the right materials that can survive that. And then there's micrometeorites. What we see as beautiful streaks of light in the night sky here with asteroids impacting the Earth's atmosphere, all of those go straight down to the surface on the moon. There's no atmosphere to burn those up. So it's a very, very challenging environment. But perhaps, as the Apollo astronauts pointed out, potentially one of the biggest challenges of the moon is the smallest thing on the moon, and that is the dust. The dust on the moon is fundamentally different than the dust here on Earth. It is not smoothed by water, wind, rain, and other elements. It is sharp on a microscopic level. It is the result of impactors and smashing the rocks together. And those sharp particles can stick to clothing and stick to materials. They're even electrostatically charged. It's hard to clean surfaces. As the Apollo astronauts pointed out, the dust might be one of the hardest things to overcome when we go back to the surface of the moon. But luckily, there's a lot of great technology that can overcome this. But all in all, if you're in the real estate business and you want to plant a flag on the moon and build a base, if you can find a cave under the surface of the moon to protect you from all of these elements, and the caves really do exist. There's actually one that could fit a city of Pittsburgh or even Philadelphia inside of it. It's massive caves. If you find a cave at the pole of the moon, near frozen water, near a peak of persistent light for some solar, and near some of these metal deposits, that's where you want to plant your real estate flag. And that's where ultimately, I think as a species, that'll be the first places that we will go. America is returning to the surface of the moon. This is a part of a grand program called Artemis, where there is a plan to land the first woman astronaut on the surface of the moon this decade. It's incredibly exciting. And we want to go, not just to go back once, not just to plant a flag, but to go back and create a sustained long-term presence there with regular routine sorties back and forth to the moon, with a gateway that's orbiting the lunar surface, and a whole series of robotic missions like the ones that we are leading for science, for exploration, for building the infrastructure, the very foundation of what our astronauts and what the future explorers of the moon will need to survive. But we're not alone. Russia and China have plans to build a lunar base, and they're already working on it. The two missions that are on the surface of the moon right now, with a rover on the far side and a lander on the near side, are both Chinese. The US has not touched the surface of the moon in almost 50 years with a lander, soft touch. We did have an impactor that hit it. So we have a little catch up to do, but luckily NASA, through leadership in particular of Thomas Zurbuchen, who is in the room here, has taken a great leap forward and commissioned a program called Commercial Lunar Payload Services. And for approximately $1 billion, they have awarded 7 lunar commercial missions that will be flying and landing on the surface of the moon in the near years to come. This is a big step, because just going back 3 years ago, we had none on the books. And we, of course, are 2 of those missions flying up to the surface. So we've got some work to do, but we need that political will and that support to continue to compete on the surface of the moon in a big way. So let's talk about our first mission. So this is the mission that is quite literally leading our nation back to the surface of the moon. It's being built right here, a block from where we sit right now, the same place that you are all invited to visit later tonight. This will be the first commercial lander to return to the moon. It's the first lander from the US that will return to the moon since Apollo, so nearly 50 years since going back. And again, the spacecraft is being integrated right here in Pittsburgh. This is where we go. This little logo up here in the top right. This is a place called Lacus Mortis. For the Latin scholars in the room, that translates to Lake of Death. Dramatic name, but actually a pretty benign location. It's called a mid-latitude, so it's not quite as hot as the equator, and it's a little nice flat landing site, trying to make it as easy as possible on the first mission. Now onto the hardware. This is the hardware that is going to take payloads up to the surface of the moon and is being built right in our clean room right now. This is a shot of our clean room. This is the solar panel that's going to provide the power for the spacecraft. These are the landing legs that are going to absorb the impact of landing. They actually have crushable honeycomb inside so that the lander doesn't bounce on the moon, so it just sticks its landing and hits. This is a descent sensor that actually is an altitude sensor flying down to the surface of the moon. It's very important to know how high you are off the ground as you're coming in for landing. This is the battery, a lithium-ion battery that's going to be powering the spacecraft, rechargeable, of course, by the solar array that I just showed earlier. This is a thermal control unit. This is notable because this was built up by our engineers in our shop right here in Pittsburgh with regional suppliers providing the boards for this. This is an Astrobotic built unit. This is the the smarts of the spacecraft that are going to control the spacecraft thermally. And I spoke about how hard that thermal environment is. This is everything that's inside of this box. These are some of the customers, the payloads that are flying with us. This is a NASA payload called it's M-SOLO for short. You can read the full name here. This is a neutron spectrometer that's looking for lightweight, light molecular weight activity on the surface of the moon, trying to basically get a sense of what the materials are like on the surface. And in partnership with this neutron spec, they are looking at the different materials on the surface of the moon and trying to figure out, is there water? Are there these other materials like rare earths? What composition is there in? These are practice experiments that are going to also be part of our second mission, where the rover is going to actually drive into a permanently shadowed crater and drill for water. So these first experiments on this first mission are just to test these instruments out. More payloads from all over the world, in this case, and all over Pittsburgh. The picture in the bottom left here, this is a rover that was built by students at Carnegie Mellon. It will be the first university rover to ever land on a planetary body, built right here by students at CMU. And the picture in the top right, for those that have traveled to Japan or Asian countries, you might recognize this name. It's Pocari Sweat. It's a drink that they have in Japan. Inside of that is a time capsule with hundreds of thousands of dreams from children from Asia. And what they're doing with the drink, when they sell a drink, the little pop top that you get, it's actually a key to this time capsule. So the kids of Asia are actually getting a key to the time capsule that will live on the surface of the moon, and someday they can go there and open the time capsule. And by the way, there's a little bit of their powdered form of their drink in there that you can mix with moon water so you can have their drink on the surface. So a fun marketing side of it. So a whole array of payloads, and again, we are tripling the number of nations that have ever operated on the surface of the moon just with this first mission. And all these payloads are right now sitting in our clean room right up the street, ready to be integrated to the spacecraft. A lot of testing is also going on. This is what we call our flat sats. So this is all the avionics and components and electronics of the lander all hooked together on a table, running software and hardware in the loop tests to make sure that everything can work smoothly and correctly the first time down for our landing. And then we take all of these units and we put them through a testing regimen. This is our thermal vacuum chamber up at Astrobotic, as well as our shake table on the picture on the left, where we're testing the environments. We want to shake it, we want to bake it, make sure it can go through all the environments that we'll experience in flight. And this is one of our control units, thermal control units again, that's going through that test. And that same box is now integrated onto the panel that will then be integrated onto the lander. So that's that box in the middle here. And our fantastic avionics team that put this together, that made this box a reality. And I do want to point out Victoria in particular, who led this development, who is in the room right here. Fantastic, fantastic development. We are flying on a Vulcan launch vehicle. This is the upgraded Atlas V launch vehicle that United Launch is flying. This is a picture from earlier, I believe it was this year or maybe late last year, where they were doing tank testing, getting ready for the flight. So things are on track for a flight in Q4 of this year for this. They expect to get the BE4 engines, or the engines by mid this year. And they're, as far as we know, on track for the end of the year for flight in 2022. So again, once we build up the spacecraft, we've got to test it. And the test can be quite violent, as you can see here. This is the entire spacecraft being tested on a shake table. We are simulating the G-forces that the spacecraft is undergoing. So it's quite a load. And this spacecraft right now, as in this video, is actually loaded up with thousands of pounds of steel to simulate the mass of the full fuel tanks being shaken with the vehicle. We also have great developments on our engines, which will be delivered imminently to our clean room here. It might look like the engine is sputtering, but that's actually by design. It's called a pulsed engine. It's quickly turning on and off to generate different levels of thrust. So you can see it getting nice, quite red and hot there. And then the legs. So the legs are really important because we don't want to bounce on the surface of the moon. So we've got crushable honeycomb inside of these legs that can absorb the impact of a landing and make sure that it's a nice, soft landing. These are legs that were developed by Airbus in Europe. And mission control. This is our mission control in Pittsburgh. which you will all be able to see later today. This is where the action is going to happen. So it's no longer Houston, we have a problem. It's Pittsburgh, we just landed on the moon, and it happens right here. So this is mission control. We've been doing numerous simulations of the actual mission, where everyone will be at their stations and ready to go. And finally, I'm going to show you the lander that will lead America back to the surface of the moon. Maybe not. So you'll have to come see the real lander tonight. So it is in our clean room. It is being integrated right now. I just saw it this morning with a tour with Senator Capito. We actually have United Launch Alliance here today too, integrating and doing a test fit of the lander onto the actual launch integration adapter. So getting ready again for launch later this year. So please come check out the lander tonight. It will be a blast. Now onto our second mission. So this is the Griffin Viper mission. So this is a very, very important mission that will deliver a 1,000-pound rover to the pole of the moon. This is the lander here is just a mock-up that is being used for egress testing, and the rover on top is just the mobility part of the rover. The rover is much bigger than as shown here. But this is a really important mission because this rover will be delivered to the south pole of the moon. It will drive into a permanently shadowed crater, and it will drill for water. And again, as I mentioned, water is that critical component that can be turned into rocket fuel, that can be turned into water to drink, water to grow plants, oxygen to breathe. This will be the first time that water is ever touched and produced on the surface of the moon. And it will ground truth all of our orbital data. We have orbital data that says that water should be there, but we actually don't know how much. We don't know what concentration. We don't know what it's attached to. That's what this mission is all about. It's an incredibly important mission, and we are so honored to be a part of this mission and to be leading it right here in Pittsburgh. This lander is actually the largest lander of any kind since Apollo. It is a monster. This is a 16-foot diameter lander. It's thousands and thousands of pounds of fuel. We'll get some pictures in a minute of people next to it, but it's a monster. So remember, our first mission goes to that upper right-hand quadrant. Second mission goes down to the South Pole. That's where the water is at. And again, this flies next year. So on this flight, we're going on a Falcon Heavy. This is a larger launch vehicle than our first launch because this is a much bigger lander that needs to fly to the surface of the moon. We are building the structural model of this lander. So this is the bones of the lander that we're building up to make sure that we've got the design right, that it can survive all of the environments. We've been building this up on site in Pittsburgh. What we do here is we build up the structural model, and then we attach masses to it to simulate what it's like to have full fuel tanks and everything else on here. So this was then boxed up and shipped out to our test site. And this is actually the Griffin lander at the test site out in California, where it's going to be first acoustic tested, and then imminently it's going to be vibration tested. So that vibration video we saw earlier, we're actually putting this spacecraft on one of the country's largest shake tables to shake this thing, because this lander has the mass of several cars attached to it in the equivalent of fuel mass. So it's a really, really, really heavy vehicle that we need to test and shake. So we have passed acoustic testing with the structural test model, and that testing went well with great results. Acoustic testing is a really interesting part of space testing. It is literally about 1.5 times the speakers of Heinz Field stacked up around the lander. You turn the volume all the way up, and then you go through all the different frequencies to see how the lander reacts to it. You literally have to be several football fields away from this because it's so loud, even with earmuffs on. So it's a really, really challenging test for the vehicle. So any big flat panels can have an acoustic reaction to it. Things passed well there. So now the spacecraft is going on to vibration testing, and it's being instrumented as we speak out on the West Coast. So we've done a fair amount of egress testing as well. And again, this lander is planned for landing in 2023 at the pole of the moon. So just a little bit about Astrobotic and how we got started. I like to think of us as a blue-collar space company. We were founded 15 years ago. This is actually a picture, I think, about 7 years ago or so of Astrobotic. We were founded in 2007 amidst a global financial crisis, and around the time that Constellation, which was the prior big push to return to the moon, was canceled. So here we were in Pittsburgh, a little space company saying we're going to land on the moon and we're going to do it commercially, and NASA wasn't going to the moon. So it was a very, very challenging environment for many, many years. But interestingly, we found it easier to raise revenue by small contracts, SBIR, STTR programs, in particular NASA's space technology side of what they do, really ended up being for us like investment and like VC financing to kind of get us started, to show our chops, to show that we can create good technology for the industry and it can be used in a broader sense. And along the way, we competed with some really big companies. There was a billionaire-backed company that we were competing with for several years, and they've since gone to wayside, and we've come out on top on that one. We also turned down millions of dollars from other states to attract us away from Pittsburgh, Florida in particular, and others. But we turned it down because we wanted to stay here. We're committed to Pittsburgh. Pittsburgh is our home. We see it as an advantage for space robotics, for the robotics talent that comes out of the local universities and what it can feed into us as a company. So Astrobotic is really the small guy that's trying to beat all odds. We in the modern version of Astrobotic, we only raised about $500K. And we turned that into $325 million of NASA contracts and counting. So quite a return on that investment. And that's more than 50 contracts. We went from 18 people just 3 years ago to 168 people and counting. We've now filled our 47,000 square foot facility, and we're already thinking about the next one. We have hired a tremendous amount of experience in the company. So Astrobotic might not have that heavy flight heritage, but the people that work for Astrobotic do. We have hired more than 750 years of combined spaceflight experience across our workforce. And that's interesting. A fair number of those people actually were Pittsburgh boomerangers. People from the region who saw Astrobotic working out in other parts of the industry were able to come back to Pittsburgh and work in Pittsburgh in space, be near their families. Very, very, very fun part of our workforce there. And now we're the largest NASA contractor by revenue in the region. And again, starting from very, very humble beginnings. We are an 85% employee-owned company, something that I'm very proud of. A byproduct of maybe not being able to raise financing in the early going, but it's a product of good engineering and good technical results, and just showing it year after year good technical results, and the persistence has paid off. And of course, with the support of NASA programs like the space technology side has really enabled us, as I'm sure it's enabled many of you other small companies out in the crowd here, and this is what could be possible for you. Just stick to it. We actually, for our whole supply chain, we do impact the region in a big way. We actually have 40 suppliers in our regional area supplying parts for our spacecraft. So you don't have to work at Astrobotic to work on our lander programs. We have machine shops, we've got board manufacturers, we've got component manufacturers, we even have shipping companies in the region that can help us. There's a whole array of capability right here in the region, and we want to leverage that more and more to build up the region and make us even stronger on the national stage. But ultimately, people are what make us great, and it's the people at the company, it's exceptional talent at the company that makes every day possible. It's building up the spacecraft. Space is truly the sum of great people, and it's about attracting and retaining those people to do something great. And in our case, we're blessed with a very exciting mission that people can be very passionate about, so we're very successful in bringing folks from all over the country. And now our job is to keep them here, to make sure that the work life is great, the culture is great, and ultimately the experience in Pittsburgh is great. But just, again, a fantastic group of folks at Astrobotic that make the everyday possible and that are building this spacecraft up. Too often in space, the billionaires get all the attention and everybody thinks, oh, Elon's doing all the work, but no, he's got thousands of people working for him. And it's the same thing here. It's really not about me, it's really about the team, the engineers that are making this possible every day. So Astrobotic is really about making space accessible to the world. And we want to make Pittsburgh and this region a destination for space. And we truly believe this down to our core, to the point where we actually created a nonprofit called the Moonshot Museum, which you'll hear from Sam Moore, the executive director of the Moonshot Museum, later today. It's a 501c3 nonprofit, totally separate organization from Astrobotic now, but we actually gifted part of our brand new facility to the Moonshot Museum so that people from our neighborhood, from our region, from our tri-state area can come and experience space up close and personal. And this is quite literally the view that the visitors will have when they come and visit. So that means anyone from the region can come, look through the glass windows, see the spacecraft being built on the other side. This is what you'll see tonight. See the spacecraft being built on the other side and imagine themselves being that person. This is how we can make space accessible. This is how we can break down barriers. This is how we can keep that spark that kids have of loving space and keeping them engaged and showing them the pathways. And then it's pointing them to programs and internships and opportunities down the road. And that's what we want to show here at the museum. And then, of course, we've got the Science Center right here, just a block away, building a Mars exhibit. So right here in Pittsburgh, we're going to have a Moon Museum and a Mars exhibit within a block of each other. And we want to connect that potentially with a spacewalk, connecting the two, where tens of thousands of Steeler fans walk every day. So big opportunity to showcase space right here. And maybe the cherry on top, we would like to build a lander model on top of the roof of our building, such that you could see it from the Science Center front door and also see it potentially in the blimp from Heinz Field. So Pittsburgh is talked about as not an old steel town, but as the city that is returning America to the surface of the moon. And ultimately, I think it's all about inspiration. It's all about showing the next generation the opportunities and giving that gift of inspiration to the next generation. Whether that turns into excitement and about space and career in space, or whether that turns into the next high-tech job or the next SaaS company or whatever else. There was an entire generation inspired by Apollo. Apollo is one of those rare moments, very, very rare moments, that almost everyone you speak of that generation remembers where they were and the story around where they were when Apollo landed on the surface of the moon. Think about that. There's only a handful of other events that could even start to rival that. And it's a remarkable thing, and people are still inspired by space. I was inspired when the Mars Pathfinder lander landed on the surface of Mars and the little Sojourner rover drove out. And I was in the 5th grade, and my teacher had me build a Lego model of that, and I thought it was the coolest thing ever. And I followed the dream, and here we are today. And I think that's the opportunity. We can spark that moment, have that spark moment for the next generation. We should hope to have that here at Moonshot, at Astrobotic, and here in the region. So my dream is that moon landings can happen on a regular routine occurrence at the space company next door, the one you can go and visit. So our story is still being written, but we have overcome insurmountable odds. There are so many reasons we should have failed, and we almost did several times. But it's really our persistence and passion that came through, and just drive to try to make this a success. And that's really what it's about, and that starts with the spark at the youngest age to really plant that seed forever. So if there's one thing I want you to take away from the talk today, it's that if Pittsburgh and this region can land on the moon, we can do anything. Thank you. And I think if there's any questions, we do have a few minutes for questions.
Just a quick question. I don't really need this microphone. Are you hiring?
Yes.
We've got a very intelligent group of engineering students from WVU right here that came up. So I just wanted to point that out. I didn't mean to. I'm not putting you on the spot, but you got some talent right here.
Well, we look forward to talking. We have a robust internship program that we continue to grow. I think we've got about 10 or so interns, at least for this summer, already signed up. We're looking for more. So yes, we're hiring. We also are hiring full-time jobs as well. We're at 168 employees and growing continually. Other questions? Oh, there's one back here.
Hey, John, great talk. Can you talk a little bit about the early stage financing ecosystem in the Pittsburgh region and how that could have helped you earlier or did help you, and the companies that are going to be coming behind you?
Yeah, it's a great question. The ecosystem here in Pittsburgh. I wish I could be very optimistic and tell you a great story on that, but it's rough. It's very rough. There is some seed capital here. It's angel level, tends to be in the hundreds of K at best. And then after that, it gets very, very challenging, especially for a moon company. I remember going to a pitch day here in Pittsburgh, and it was a Pittsburgh Venture Day, and everybody was out, in their suits and doing their pitches. And I remember going up, and literally the judges laughed the entire time during my pitch, because they just couldn't imagine that there's a space company in Pittsburgh, and that much less that we could be successful building a business doing that. So that's something that we want to change. And the more that we can show success here in Pittsburgh, the better that can be. But additional resource here, additional equity investment is sorely needed. I encourage whenever possible when I meet outside investors to show that Pittsburgh has some really great tech going on. And I'm hopeful that our exclamation point of a moon landing can help attract even more attention and showcase the possibilities of what's possible here in Pittsburgh. One here.
Thank you. You mentioned how you had to send the lander to California for vibration testing. I'm sure there's a lot of other testing and things you have to do that require you to send it to the space ecosystem that's on the West Coast or in the mountain region. What's like the biggest challenges that you see with that, and would it speed up your development cycles? Is there any plans or any way the local industry can help bring some of that stuff here to speed up our development?
Yes. Testing is a critical part of every spacecraft development program, because you simply can't just go reset the spacecraft once it's launched. You really have to make sure that it can work every time. And the capability and the scale of testing that's required is large for these things. For the Griffin lander, there's literally only a handful of facilities in the world that can handle the shake test that we were doing. And some of them were booked up already, and the only one that was available was on the West Coast. So it wasn't by choice, it was literally the only one available. And then there's thermal vacuum testing too that we need to do at scale. If we can have that capability locally, or even just regionally, it could save us a lot of time, increase schedule assurance, which helps us competitively when we're competing for NASA and DoD and other opportunities for space programs. So I'd encourage us as a region to think about that testing as a core capability to build up in the region, to attract more and more capabilities. And some of that testing does exist very capable testing does exist at NASA Glenn. But there are challenges with schedule, and sometimes they're not the cheapest. So we just need a little more capacity in the system to kind of help things out there. So that the more the merrier on the testing side. And just to give you a sense of it, it is not cheap to ship spacecraft. We spent, a couple $100K on a specialty box that is humidity controlled, temperature controlled, vibration isolated, just to send the spacecraft over the road. So the more local it is, the easier that is, and more effective and better schedule management we can have. So thank you for that question.
You were mentioning about NASA's Artemis mission and the Eventual gateway that they're going to be building. Do you have plans to be involved with that at all?
So we are the tip of the spear, actually, for Artemis. So Artemis is the plan to return humans to the surface of the moon, but the precursor is the robotic missions right now. So our mission later this year will be the first of the Artemis return to the surface of the moon. Over time, we see us as our opportunity is building infrastructure and robotics that can support and develop astronauts on the surface. So right now, astronauts are limited by when the sun sets. They're limited by how much power they can generate just by the power that they bring with them. So if there is a power station on the surface of the moon, which is something that we're looking at very closely and developing, that could be super enabling. You could have long-term sorties there with support. If we're able to extract water and actually have rocket fuel there, you can have even more increased capabilities, because then you can count on refueling down on the surface for your return trip. And then with Gateway is a really exciting enabling capability because it's is a comm relay. And if you're on the far side of the moon, you can't communicate directly to Earth. You have to bounce your signal off of something, and Gateway is that opportunity. I also think it's a great opportunity because it reduces the time between for a signal to be sent back and forth from the Earth to the moon. Right now, a signal would take between physics and ground network delays, anywhere between 10 and 30 seconds round trip for a command to go back and forth to the moon. But if you had Gateway in orbit around the moon, you could do telerobotic activities. Imagine an astronaut with VR goggles and some gloves manipulating a robotic hand or arm down on the surface of the moon that can be looking at samples. You could do human-assisted robotic activities on the surface in dramatically better ways than what we do today. Not to mention the untold experiments and fantastic outcomes that could come from learning to live in deep space. If you think about where we've been to space, we've only just scratched the surface, even though we've lived in space on order of 40 years so far with different space stations, but we've never gone beyond Earth. We've never lived beyond the moon for more than 2 weeks. That's the sum of all of the astronaut time during Apollo. So we need to learn to live outside and beyond Earth, and Gateway is a fantastic gateway, quite literally, to the rest of the solar system.
Thank you so much for your wonderful talk. My name is Anna Volker, and I run a nonprofit here in Pittsburgh focused on disability inclusion in STEM called SciAccess. And I was really intrigued by the last question where you were talking about infrastructure on the moon. And I'm curious if Astrobotic has looked at how that infrastructure could be more accessible for future astronauts with different types of disabilities. Thank you.
Great question. I think that accessibility is so important at every level. Space needs to be a place for people of all backgrounds, of all capabilities, of all disabilities, to be able to do great work and to show that, because that's what makes us great. That's where the best ideas come from people from different backgrounds. So the more that we can provide the infrastructure to support the astronauts, the less they have to rely on bringing that every time they go. So power, communications, potentially over time, you could potentially make roads with robots, potentially extract those resources from the poles of the moon and the deep craters. That's going to enable it, because that's going to free up mass on the landers that are going to go for everything else that you might need to support astronauts and good science and exploration work. So thank you.
How does the acoustic frequencies affect the spacecraft?
The acoustic what? I'm sorry?
The acoustic frequencies.
Acoustic frequencies, yes. Yeah, so that was the picture that I showed earlier of the giant speakers. So how does it impact the spacecraft? If you've ever been to a rock concert or like an outdoor concert and you've gotten close to those big speakers and you feel your body shake, that's what happens to the spacecraft. And in particular, it's the big flat panels, it's the drum effect that has a big impact. So what we need to make sure is that the spacecraft can survive that. That it doesn't have frequencies that start to couple with the launch vehicle, i.e. have the same frequency of the launch vehicle and have bigger and bigger and bigger vibrations that something could crack or break. So the acoustics are a very challenging thing to simulate as well. So typically you really have to do the testing, at least for now. I know ANSYS is in the room. So there's still more capability we could do in the acoustic testing analysis side. There's a question here.
Actually, two questions, John. First of all, how many subcontractors do you have approximately in your supply chain?
We have 40 in the region. I haven't counted all of them nationwide or worldwide, but a lot more than 40.
Excellent. Second question, how do you pick, or how did you choose ULA as your launch provider as opposed to, say, SpaceX or whoever?
So we've actually chosen both so far. So we're going with ULA on our first launch, and we picked ULA because they are a very reliable launch vehicle service. They're one of the most reliable launch vehicle services in the world. They have a storied history of success with their Atlas V and other launch vehicles. They were also a great partner to us as we were growing up as a company, and that's very, very important for the big guys to help the little guys. So they were a big help with that. And of course, at the end of the day, they had a price point that we could afford. For the second launch, we are going with a SpaceX Falcon Heavy. It's capable, it's reliable. That's very important for that mission in particular because it's got to be successful. We thought that was a great fit. And again, a price point that we could afford with the contracts that we had received.
Excellent, thank you.
Thank you.
Hi, John.
Hi.
Where do you see Astrobotic in 30 years, 50 years? Where do you hope?
Yes, Astrobotic in the future. At the core, Astrobotic is a space robotics company. Our landing service is just what we're doing now, and I think it's just the beginnings. So I see Astrobotic as having a lot of surface systems, everything from power and infrastructure on the surface of the moon, where we're not just selling kilograms delivered to the moon, we're selling watts, we're selling bits. We're the local power company, we're the local communication company. And then enabling all of that capability to add up to long-term human bases on the surface of the moon. And then even beyond the moon, we're also looking back toward Earth. We have a big push in our space robotics side to be looking at opportunities for commercial and even DoD applications for space robotics more broadly. So think any kind of satellite-to-satellite interaction for refuel, maintenance. There's some DoD interest in that as well. So I think it's a whole array and a range of that. And then possibly, if you're talking 30, 50 years into the future, I think that's when we're going to be a regular, routine, capable mission provider for much more complex missions going out into space. I think we could be a commercial alternative to the larger programs that are going out there. So thank you. I did see that we've just run about out of time, but I really do want to thank you again all for coming today. And my last thought here is that only 3 nations have ever landed on the surface of the moon, and they were all superpowers. The Keystone Nation will be the next. Thank you.